Alright gang, I'm going to work out all 25 review problems to help prep you for the Unit 5 Celebration of Learning on Tuesday. It's going to take a while, but you're worth it. Alright, let's roll. Okay, first problem. The y-intercept, you can tell, is -3, so we're going to go down to -3. 1, 2, 3, put a nice dot there. And then you can tell the slope is whatever's in front of the x. So if there's not anything there, it's a 1. So it's 1 over 1. So from that point, we're going to go up 1 and over 1. That's the rise over the run. Then we're going to just connect the dots. And there's our line. Then we're going to do the next one. The y-intercept is 2, so we're going to go up to 2. The slope is what's ever in front of the x, so there's a negative there, so it's a negative 1 over 1. So again, that's your rise over your run. So from that point, we're going to go down 1 because it's negative, but then we're going to run over positively, and we can do that a few more times. And this one's a little bit tough to solve by graphing because of where they cross. They cross at this spot right here, which is supposed to be 2.5 comma -0.5. And we'll give you a better one on the test where it'll cross at integer spots. So this one's probably better to do maybe solving by substitution or elimination, but nonetheless that's how you graph the lines. Sorry, trying to get to number 2 here. Oh. Okay, number 2, both of these are in, actually the top one's in slope-intercept form. So we're going to go up to 1, put a nice dot. Then the slope is up 2 over 1. So we're going to graph that. And we can do that again. So there's that one. This one on the bottom is not yet in slope-intercept form, so we would want to add 2x to each side. So that will cancel out. So y equals 2x minus 3. And then we're ready to graph that one. So you can tell the slope, or the y-intercept, is -3. So then we go and look for the slope, so it's also 2 over 1. Now because these two lines have the exact same slope, they're going to be parallel lines, and they're going to have no solution. So we're going to say no solution. They don't ever cross. And you can tell that right from the beginning, or almost from the beginning, that the slopes are both 2. Okay, number 3. This is taking a little bit longer, my little pad. Okay, my y-intercept is 3, so I'll put a dot there. And then the slope here, I have to decide where I want the negative to be. So I'll just put the negative on the top. So that's my rise over my run. So from there I'm going to go down 1 and over 2, connect the dots, down 1 over 2, down 1 over 2. And then the other one, I'm going to graph that with x and y intercepts. So the x-intercept turns out to be 6 if you put a 0 in for the y. So 1, 2, 3, 4, 5, 6. There's 6. And then the y-intercept is if you put a 0 in for the x and you solve for y, so you would get, if you go 0 plus 2y equals 6, then you get 2y equals 6, so y has to be 3. So that means the y-intercept is 0, 3. So we look at this, And you're like, wow, they're the exact same line. So whenever that happens, they're the same line, they have infinitely many solutions. Infinitely many solutions. All of the ordered pairs that fall on the line are actually the answer. Infinitely many solutions. Okay. Number 4. Okay, this one is really good to do with x and y-intercepts as well, even though probably need a little bit bigger graph. The x-intercept here is 9. That's if you put a 0 in for the y. So we'd go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be a little bit off there. A lot of bit off, actually. And then the y-intercept is -3. So we go down to -3. And then we would connect those two. So there's one line. And the other one's really good to do with x and y-intercepts as well. So the x-intercept is 1, because you put in a 0 for this one, so that would give you 2x equals 2. So x will be 1 if you divide by 2, so that would be 1, 0 is where that intersects. And then you do the same thing for the y. You put a 0 in for the x, and then you get 2y equals 2. So the y-intercept will actually be 1 as well. And so they will cross. And it looks like they cross at 3, -2. And that turns out to be the solution to the system. 3, -2. Still good? Hopefully. Alright, number 5. We're going to solve systems of inequalities now. So the first one, this one here, is just a vertical line at -2, and it's solid because it doesn't have it does have a bar underneath it. And then it says that it's greater than, so we would shade this way. And the other one is a horizontal line at 3, so I go 1, 2, 3. And this one's dotted because it doesn't have a bar underneath it. And it says that it's less than, so we would shade down. And then what we would do is we would look to see where they overlap, and you can tell they overlap in this region here. So this would be the solution. Only the part that I have shaded in a little bit darker is actually the solution to the system. Okay, this one is similar. The x is less than 5, so we're going to go to 5. 1, 2, 3, 4, 5, and this one's dotted. And it says that x is less than, so we're going to go this way, to the left, because the numbers are smaller. Then the other one is in slope-intercept form, so we're going to go down to -3, put a nice dot, and then we're going to go up 2 and over 1, and that's going to be dotted, 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 again, because there's no bar underneath it. Now I know that this one's going to be shaded above because it's greater than, but we should do a test point, so we use 0, 0 as our test point, if it's not on the boundary itself. So 0, 0, if you plug that in, you're going to get 0 is greater than 2 times 0 minus 3. So 0 is greater than -3. Let's see, that is true. So I'm going to shade the side that has 0, 0 in it, which would be this side, so I shade this way. And what I would do is look for the points that are overlapping. So you can tell the red goes to the left, the blue, and so everything that would be in common would be from here on. You can tell the parts that are overlapping. Okay? Number 7. Both of these are in slope-intercept form. So we go down to -2, put a nice dot. The slope is -1/2, so we would go -1/2. So down 1 over 2, down 1 over 2 if you wanted to just not have to use a straight edge. And then it's solid, has a bar underneath it. And then the next one's in slope-intercept form as well. So we go up to 3, put a nice dot. Your slope is up 3 and over 1. 1, 2, 3 and over 1. Dot. This one's dotted. No bar underneath it. Dotted, dotted. Okay. And then we have to determine some shading. So the one on the top, I would do a test point of 0, 0. Actually, both of them I'm going to do 0, 0. So I plug in 0 is less than or equal to. Now all of this would be 0, so I'm going to go ahead and show it. So -1/2 times 0 minus 2. So 0 is less than or equal to, all of that 0, and then is 0 less than a -2? That would be false. So that means I don't want to, this is the one, the red one, I don't want to shade the side that has 0, 0 in it. I want to shade below. And then I'm going to go to the other one here. So I'm going to plug in 0, 0. 0 is greater than 3 times 0 plus 3. So 0 is greater than 3. Is that true? That's not true, so I don't want to shade the side that has 0, 0 on it. I want to shade the other side. So I shade this side. And then I look to see where they overlap. And you can tell they overlap in this region. So I would shade that a little bit darker. And that's the solution to the system. Okay, number 8, once it comes up for me. Okay, both of these are in standard form. They're good to do with x and y intercepts. So the top one, the x-intercept is 4, 1, 2, 3, 4, nice dot there. Y-intercept, 1, 2, 3, 4, and then it's solid, so I'll go ahead and do that. I'm going to go ahead and figure out the shading before the other one gets into the picture. So let's do a test point of 0, 0. So we got 0 is greater than or equal to 4. That is false. So I don't want to shade the side that has 0, 0 on it. I would shade this side. Then the other one is good with x and y intercepts. So the x-intercept is -3. So there's that point. Y-intercept is -3. 1, 2, 3. And this would be a dotted boundary. And I would do a test point, 0, 0. So 0 is less than -3. That is also false, so I don't want to shade the side that says, or the side that has 0, 0 in it, so I would shade the other side. So this one would have no solution. So no solution is the answer, and really, graphically showing the solution would be a blank graph, because it would show that there are no points in common. But I like this graph because it shows all the work. Okay, number 9, once it shows up for me, substitution. So we're going to take the 3x and we're going to plug it in for the y. So we're going to take it and just put it right there. So it's going to be 5x plus 3x equals 24. So we're going to have 8x equals 24. X equals 3, and then once you figure out the 3, then you can go ahead and just plug it in right there to figure out what the y is. So y equals 3 times 3, which is 9, and then we put the two together as an ordered pair, 3, 9. And remember, you can always check your answers. Number 10, once it shows up for me, it's a little slow. So x equals 2y minus 1, so we're going to take that and plug it in right there where there's an x. So it's going to be 2 parentheses 2y minus 1 minus y equals negative 8. So then we're going to distribute that. So it'll be 4y minus 2 minus y equals negative 8. We're going to combine our like terms. So we have 4y minus y. It's 4y minus 1y. So that makes 3y. And at the same time, we can go ahead and add the 2 over. So we have 3y equals negative 6, and then divide by 3. So y equals negative 2. Now if y equals negative 2, then you can go into the best spot to try to figure out what the x is, which in this case would be right in that top equation. So this would be x equals 2 times y, and now we know y equals negative 2. So 2 times negative 2 minus 1. So x equals negative 4 minus 1, which is negative 5. So we put the two together as an ordered pair. We got negative 5, and then we got negative 2. Looking at 11 here. This one's great for substitution, so we're going to take this y equals and we're going to plug it into the other equation. So that gives us negative 4x plus 1 equals negative 4x plus 5. And when we go to solve this, we would add 4x to each side. And you'll notice that they cancel out, and that would give you 1 equals 5. When you lose your variables and you get a statement that doesn't make any sense, then you would say no solution. If you lose your variables and you get a statement that does make sense, then you would say infinitely many solutions. Okay, another one of substitution. X equals 6 minus y, so we're going to take it and plug it in there. So this would be negative 4 parentheses 6 minus y plus y equals 21. So we're going to have negative 24 minus, actually plus, we have a negative times a negative, so that's going to be plus 4y plus y equals 21. We're going to have negative 24 plus 5y equals 21. 5y equals, and then you can add the 24 to both sides, solving for y here. So that's going to give you, it's going to give us 45, and then we're going to divide by 5, so that'll give us 9. So we know y equals 9. Then we're going to go and plug it in right in that top equation. So that'll give us x equals 6 minus 9. So x equals negative 3. So we put the two together. We got negative 3, positive 9. Okay, we move on to elimination. This one here is set up perfectly for elimination, because if we add these together, the y's already eliminate. X plus x is 2x. 4 plus 2, 4 plus a negative 2, is positive 2. And then divide by 2, so we get 1. X is 1, then we just want to go and plug it in to get the y value. So we get 1 plus y equals 4. And then subtract 1, so we get 3. So 1 comma 3, and then of course you can check it, make sure it makes sense, and it does. We're on number 14. This one's almost set up perfectly for elimination. We should multiply the top equation by negative 1 on both sides, so then that would give us negative 2x minus 3y equals a positive 2, changes the sign on the right. Then I'm going to just rewrite the bottom one so it's a little bit closer. And now we're ready to add these guys together. When we do, the x's eliminate, and then we have negative 3y plus 5y, which is 2y, equals 4, and then divide by 2, so y equals 2. We need to go somewhere to figure out what the x is. So we can go into any of these, but I'm going to just go into that bottom one there. So it's going to be 2x plus 5 times 2 equals 2. So it's going to be 2x plus 10 equals 2. 2x equals, and you got to subtract 10, so that would make it minus 8. And then we're going to have x equals, and if you divide by 2, you're going to have negative 4. So we put those together, we're going to have negative 4, comma 2. And 15. This one's going to be elimination as well, so let's come up with a plan. So probably try to make this top one a negative 2. So let's multiply that top one by negative 2. That will become negative 12x minus 2y equals negative 32. I'm going to rewrite this other one, just make it so it's the same color for me. And then, so I'm not changing it at all. Now I add those together, and you can tell that the y's would eliminate. So negative 12 plus 3 is negative 9x. And then we've got negative 36. And then divide by negative 9 on both sides, so that would be 4. If x equals 4, then we need to figure out a good spot to plug in the x so that we could get the y. So we're going to go 6 times x, which is 4, and then plus y equals 16. 24 plus y equals 16. So y equals, when we subtract 24, we're going to get negative 8. So we put the two together, we're going to have 4, negative 8. Yeah, 4, negative 8. I had to check myself for a second there. Okay, number 16. Okay, we need to come up with a good plan for this one. So let's try to get the top to be negative 6 and the bottom to be positive 6. So let's multiply the top equation by negative 2, and we'll multiply the bottom equation by a positive 3. And you got to make sure you do it on both sides, same number on both sides to keep your equation in balance. Okay, the top one's going to become negative 6x. It's going to be a positive 4y, and then a positive 32. The bottom equation is going to be 6x plus 15y equals 63. We're going to add those two together. We're going to notice that the x's eliminate, so that's going to be 19y equals 95. And then that should go in 5 times if we divide by 19. So divide by 19, so you should get 5. And then take the 5 and put it somewhere good. So it looks like the bottom equation right there. So this is going to be 2x plus 5 times y, or 5 times 5, equals 21. 2x plus 25 equals 21, and then we're going to subtract 25 from each side. So that's 2x equals, that would be negative 4, so x equals negative 2. So put the two together, so that's going to be negative 2 comma 5. Number 17, pick any method that we think is the best. So this one's set up the best for substitution. So we're going to take that and we're going to plug it in for the y. So it's going to be 2x minus, and we're going to have to put this in parentheses, x plus 1 equals 3. Now because there's a minus sign there, we have to distribute it to both. So it's going to be 2x minus x and then minus 1 equals 3. 2x minus x is just 1x, so just x, minus 1 equals 3. X equals, you add the 1 over, so x equals 4, and then you take that and you plug it in at the top equation, so we get y equals 4 plus 1, y equals 5. Put the two together, we got 4 comma 5. So any method, let's see. The best method for this one would be just to add them together. So we add them together, boom, the x's eliminate. Negative 2y plus 9y is 7y. And then 3 plus a negative 10 is negative 7. So y equals negative 1. If y equals negative 1, then we just need to plug that in somewhere. So let's put it in the top equation. So it'd be x minus 2 times negative 1 equals 3. X plus 2 equals 3. So x equals, subtract the 2 from each side, so it'd be 1. So solution would be 1, negative 1. Let me see if I can find that one. Oops, on the next page. Okay, so that one's good. Number 19. This one's set up pretty well for substitution. So we're going to take the y, plug it in. So it's going to be 3 parentheses 2x minus 1 minus 6x equals negative 3. We're going to distribute that 3, so that'll be 6x minus 3 minus 6x equals negative 3. Notice that the 6x and the 6x would cancel out, 6x minus 6x, and then we get negative 3 equals negative 3. That's a true statement, and so this one has infinitely many solutions, which means they're actually the same line. They might just be in camouflage. We didn't recognize that they were the same. Infinitely many solutions. Number 20. This one's set up really nicely for substitution as well. Well, the last one, I can't remember what that, oh, it was elimination. So this one's substitution, so we're going to plug that in. So it's going to be 2x minus 5, parentheses, 3x minus 4 equals 33. And then we're going to distribute the negative 5 to both parts. So we're going to have 2x minus 15x. Negative times a negative, that's going to be a positive 20 equals 33. And 2x minus 15 is a minus 13x plus 20 equals 33. And then subtract 20. So negative 13x equals 13. So it looks like x is going to be negative 1. Then we're going to go somewhere good to figure out what the y value is. So I would say, boom, right there would be a great spot. So this is going to be y equals 3. X is negative 1, so we're going to put that in there. Minus 4. So y equals negative 3 minus 4. Y equals minus 7. So put the two together, that's negative 1 -7. Alright, so we get into the word problems a little bit. So for this one, we're going to set up two equations. One equation is for the AT&T, so this is AT&T, y equals, it's going to be $40 plus 5 cents a minute. And then the next one is going to be $30 plus 10 cents a minute. So top one, AT&T, and the bottom one, Sprint. Okay, this one's really good to solve by substitution. So we take this y value, put it in the second equation, solve for x. So 40 plus 0.05x equals 30 plus 0.10x, and then just solve for x. So subtract the smaller number. So subtract 0.05x from each side. That'll give us 40 equals 30, and then plus 0.05x, and then you'll want to subtract 30 from each side. So 0.05x equals 10, and then divide by 0.05. So the number of minutes that they would be the same would be 10 divided by 0.05, which is, how much is that? 200. So that would be 200 minutes when they would be the same. And then the question would be, well, how much would they cost? So you can plug in the 200 minutes into either one. So let's say we plug it into the y equals the Sprint one. So that would be 30 plus 0.10 times 200. So y equals, and that would be 30 plus, and then this would just move the decimal place one spot over, so that instead of 200 it would be 20. And so y equals $50. Makes sense? So then answers both questions. Alright, I'm looking at 22 right now. Once it comes up. Okay, so 8 gallons of paint, 3 brushes. So I'll use G for gallons of paint and B for brushes. So I'm going to go 8G plus 3B equals 152.50. And then the next one, let's see, 6 gallons of paint, 2 brushes. So 6G for 6 gallons of paint. And 2 brushes is 113. This one's set up probably best for elimination, so you got to come up with a good plan. So it'd be really nice if we could make the B's the same, maybe make one of them a 6 and one of them a -6. So let's multiply the top equation by 2, and then we'll multiply the bottom equation by a -3, and that will make these the middle ones there, both a 6 and a -6. So multiply the 2 through, so that would be 16G plus 6B equals, we got to do 152.50 times 2, which would be 305, and then we're going to multiply the -3 through, so that would be -18G minus 6B equals, we got to do 113 times -3, so that would be -339. Now when we add those together, we can tell the B's eliminate, so that will give us -2G equals, and this will be -34. So we'll solve for G, so we'll get 17. So $17 for a gallon of paint, and then we would just go into any of the equations to figure out how much the brushes are. So probably need maybe a calculator for that one. So I'm going to go into the bottom equation, and I'm going to plug in, I'm going to go 6 times g, which is 17, plus 2b equals 113. So 6 times 17, that should be 102, plus 2b equals 113. 2b equals, subtract the 102, so get 11. So b equals 11 over 2, which equals 5.5, or since we're talking money, $5.50. So that's how much the brushes cost. Brush. And the other one, of course, is the paint. Gallons of paint. 23, the dog walking. We're just supposed to set up a model for this, which is a system of inequalities. So we would want to say dog walking. Let's just use D for dog walking, number of hours dog walking. So that would be D. And we're only allowed to work 25 hours, so at most. So number of hours you walk the dog, plus number of hours that you are a car wash attendant, so I'll let that be C. And then it has to be at most, so at most is less than or equal to 25. And then dog walking pays $8.50, so that's going to be $8.50 times however many hours you're dog walking, plus how much is car washing pay? $5. So $5 times however many hours you work as a car wash attendant. And then where's the money? Oh, we need to earn at least 100. So at least is greater than or equal to all the time. So at least 100. So there's your model. Marcia buying plants. We did this one the other day in class as a warm-up, but we'll take a look at it again here. So we got Marcia. We're gonna let let's see, I'm gonna say X is the soil bags, number of soil bags of soil. And then Y equals the number of plants. And I know that's a typo there about the number of 4 per bag is what it's supposed to be. Okay, so she has to buy, let's do our money first. So $4 per bag of soil, and then the plants are $10 each, so $10 times the number of plants, and she can spend no more than 100, so less than or equal to 100, and then she has to buy at least 5 plants, so Y is greater than or equal to 5. So you probably remember that one. Alright, last one. So 25. We're on the home stretch, sliding into home base here. Okay, so let's write a model for this one. So let's say that, let me go with X being the babysitting hours, and then I'm going to go with Y as the walking dogs, number of hours walking dogs. So let's write a system so she can work at most 20 hours, so that would be X plus Y is less than or equal to 20. And then let's include the money now. So 6, let's see, babysitting. So 6X plus $4 per hour walking dogs. And she wants to make at least $90, so greater than or equal to 90. So this one's ready to graph. Now this is pretty good for X and Y intercepts. So the X intercept on the top one is 20, and for the Y intercept it's also 20. So then we would just graph that, connect those dots, and we would shade the appropriate region, so we would do a test point of 0, 0. If you plug 0, 0 in there, you would be able to tell that 0 is less than or equal to 20. That's true, so we'd want to shade below. I'm going to wait on shading too much, and then for the other one, the x-intercept would be, let's see, 90 divided by 6, which would be 15, so that would be right about here, and then, so this is 15, and then for the y-intercept, you want to plug in a 0 for the x, so 90 divided by 4, and that's 22.5, correct? Yeah, 22.5, so that would be right up here, since it looks like it's going up by 2 for every little tick mark, so about there. And then you would connect these dots. Whoops, something funky happened on mine. Okay, so then you want to connect those dots, pretend like that's a straight line. Okay, and then you want to shade the appropriate region, so you want to do a test point. So 0 is greater than or equal to 90. Let's see, is that true? That is not true, so that's false. So I do not want to shade the side that has 0, 0 in it. I would shade the other side, which would be this way. And you can tell the only region where they would really be overlapping in would be this little tiny area here. And so that would be your solution. So then you would try to figure out some ordered pairs in there that would give examples of possibilities for her, where she satisfies being only able to work 20 hours a week, but yet makes enough money working the 2 jobs. So here are a couple of possibilities. So 16 hours, so let's go make a little chart even. So we have babysitting. These are possibilities. Babysit and dog walking. Okay, as ordered pairs, it would be, one of them would be 16 and then 4, so that would be 16, 4, and that looks like it fits in the region. And then another one would be 17 hours babysitting and 3 hours dog walking, and then another one would be 18 hours babysitting and 2 hours dog walking. So just try to find some good points that are right in that shaded region. Okay? Alright, good luck.